Now logs work a little bit differently, so sometimes you need to take a little bit of extra time to catch up to this. Again, you can find your domain algebraically the same way we do your domain restrictions. When we say under a radical, it has to be greater than or equal to 0. When we set it greater than or equal to 0, with the log for the argument, it has to be greater than 0. We set it greater than 0. So you can absolutely do your domains algebraically. It does make sense. Or keep track of them. Keep track of your original domain. And if you're shifting 1 to the right, add 1. If this is your asymptote, add 1. If this is your point, add 1. This will give you perspective in your graph. Remember, your intercepts have to be found algebraically. And now we can do logs, so they're good. If it doesn't have a y, don't do the y. If you shift it the other way and it has a y, then we'll do the y. Then we just put x of 0, and that makes life a little bit easier. But if it doesn't have a y, it doesn't make sense to even try to do it. So remember, you're going to give me your transformation, what's happening here, and you're going to give me your new domain, your range, your asymptotes, and your intercepts. Okay? Yes.
I don't understand how you do
The x-intercept. The x-intercept, as with any other graph, for an x-intercept, we set y equal to 0. For a y-intercept, we set x equal to 0. So we take our equation and just set y equal to 0. Now, because it's a log, you can flip this to an exponential equation. It's probably easier if you put this on this side. So go like this. Now, what's the base on a natural log? E. So, flip it. So, log equals exponent. Whichever way you decide to do this. The base to the exponent equals x minus 1. So, anything to the 0 power is 1. Add 1. And this is it algebraically. Graphically, we can see the movement. We can see from the 1, 0, it moved 1 over. But algebraically, you have to do this. Now, say you had a log. Say this said log base 2. Say this was a log, right? And we set it equal to 0. Do you see it too? 2 to the 0 equals this. See it? Regardless of what base we use, the process is going to be the same. It's just with the natural log, it's a base E. Same thing when we use a log base 10, and you don't have a 10 here. To flip it, you might want to put the 10 here. 10 to the 0 equals this. We're going to go back and forth between logs and exponents. Okay. Alrighty. So the next one, all we have is a reflection when it's next to the x. The x is going from the positive to negative. It's a reflection in the y-axis. So make an exact reflection in your y-axis. You can calculate your domain this way. Same thing, algebraically, it has to be greater than 0. So I divide by a -1, flip my sign. Okay. Or you can just do the reflection. And then figure your domain. Your range is not changing. Your intercept reflected. Algebraically, if you find your intercept, set y equal to 0 again. I don't think I did that algebraically. If it helps, flip this around. I know a lot of kids like to look at it this way instead. E to the 0 equals -x. So this is 1. And divide by a -1. And there's your intercept. And your graph should help you see the intercept. Excuse me. Questions on any of this? It's always a little bit more difficult when you look at the transformations using a log, which is why I gave you the rules written out for logs. And you want to remember your base keep track of your base of your log as well. Okay. This we have a shift up, down 5. You're having a vertical shift down 5. Again, your range is not changing on a vertical shift because it was all real numbers, and your domain is not changing on a vertical shift. The only thing that's going to change is your x-intercept. Your asymptotes stay the same. Set it equal to 0 and just work it out. Technically, if I ask for the exact intercept is e to the 5th. Because we had to round this, but in precalc we round to 3 decimals. So either way you want to give it to me is fine. Question? Yeah? 97. Anybody question on this one? Okay, we've got a two transformations, a horizontal shift to the right first, and then a vertical shift up 2. The range again is not going to change. Your domain, when you shift over, yes.
The x-intercept, I just want to make sure it's 1.135, right?
Yes.
Okay.
Every time my page changes, something happens to my page change. I don't know why.
Yeah, no, I just wanted to make sure because
Yeah.
my eyes are a little concentrated.
I don't know what happens to my page change. I must have maybe an old word or like an old version when I did this compared to the new one. Excuse me. So is everybody okay with the transformation? Okay. So we get into some of your rules. So you have to expand. You have 3 basic rules. Your product rule, since logs are exponents, they have the same format. If you were multiplying like bases, you added your exponents. So when you multiply, you're going to turn this into an add. When you divide, you're going to subtract. And the power rule is nice because that allows you to bring your exponent down. Again, I throw one extra rule in called my root rule. Change this guy first to an exponent and then bring it down. Questions? Everybody's good? You tell me if you have any questions, otherwise I'm going to go through these. Okay? We've got 3 factors in number 55, so separate them all out. Same thing with this one, 3 factors here. After you separate them out, bring down your exponents. If you can bring them down all in one step, that's fine with me.
You did separate them on number 61.
I did? You don't have to. I did, yeah, but you don't even have to.
You don't have to.
No.
But if you did, would you have to put the 2 ln x plus 1 and x minus 1? Would you have to put that in parentheses because that's the whole
You would just leave this in parentheses. Because say this was, and I probably did this, but if you say this was this, whatever this usually is, we leave it here. Even if it said 2x minus 2, we never really factor it out or anything, but you can do it, but you can just leave it like that. Because there's really nothing else you can do with this.
Okay.
No lower than this. Because if x was a 0, we would have a problem here.
So is that just like a formality?
Yeah, that was just like part of the problem in the book, isn't it? Well, I took it out of the book. Because what happens to your domain? Can your domain be 0?
No.
It has to be greater than 0, right?
Yes.
Normally your domain says x is greater than 0, but because we can't have a 1 in here, this will give us a 0. If we put a 1 in here, this will give us a 0, which will say the ln of 0, and we can't do this. So that's just like a clarifier. You solve it the same way, knowing that x has to be greater than 1. Because if we put a 1 in here, we're in trouble. Normally your domain is, you're right, x is greater than 0, but this one has a little problem in the numerator. Again, you're going to expand these guys out. If you want to keep parentheses around the first two, it's fine. You really don't need them because order of operations, they come first anyway. But if you're more comfortable putting parentheses around these guys, this is fine. Doesn't hurt anything. You would need it if it was last. But order of operations will work this way anyway. If it was the other way around, you would need if it was a minus this mess over here, then you would definitely need your parentheses with the minus sign. Put a plus sign, no. Okay. All right, this one we were condensing that into one. Just reverse your rules. When you added, you had a product, bring it back to a product. When you subtracted, you had a quotient, bring it back to a divide. Always pull your exponents up first. Get rid of that power before you do anything else. And then last, when you bring this up, make sure you go back to a radical. That's where our 1/2 came from. Are we good with these?
Projectors is not lined up with the screen. It's weird.
It is. Somebody must have twisted that a little bit because as it gets down here, I can't turn it.
It's like kind of like this.
Yeah, I know. I tried to move it, but I'm afraid I'm going to break it off.
Like,
Not by my strength, by just twisting it, you know? That's all I need.
Technology in this.
I know. I never got my new light bulb, so thank God Mr. Schaefer got me an old one.
Schaefer's a good guy.
Yes, he is.
So I'm just kidding.
How about that last one? Everybody good with that last one?
Yep.
Okay. Now you could absolutely leave it like this. This is fine. Or you can bring it back to this. Same kind of thing with the x squared minus 1. I don't care which way you give it to me. It's fine. Is this the last one?
There's another page.
There's another page.
Yeah.
Down. Okay, evaluate. I threw these in, just evaluate. Now, if you want it, whichever way you want to do this, in your calculator, you have a log base. If you have an 84, you have to do the change of base like this guy. If you don't have an 84, you have to do it this way. Just put a line. What stays above, goes below. We converted this to base 10. This is actually base 10 in here.
I did it algebraically.
And algebraically is fine. Generally, I will say to you, algebraically. Algebraically means you have to do this.
Yeah. That's
Yep.
right.
Okay, the L and E's. What happens here is your exponents come down. So you simply have 3 minus 7. There's your property. The L and E cancels itself out. Again, your exponent comes down here. You're going to multiply 4 times 2. And the L and E is gone. You're not going to square 4. You're going to bring it down and multiply it. Or if you brought it up the other way, you'd still be multiplying when you raise to a power. Just another extra day at it. Again, you can absolutely use your change of base in here. You can put it in your calculator with this part, or log x divided by log 7. You know that it's a basic log. So, does anybody remember what the 7 does for the base? Well, okay, let's compare. Let's compare. What would the difference be?
Does it like
What's the difference? when I graph this.
When,
Oh, it's how, like, stretched it is, right?
Kind of how stretched it is. Kind of how close it sits to the axis. Let's see if I can put this in front. Okay. So here's my graph 2, log 2. It's going to be a little bit wider. And what's going to happen to my 7?
It's gonna have a sharper turn.
It's just going to have a sharper turn. It's going to come up here a little closer to here and a little bit closer to here. Same thing with your exponential curves. When we did a 2, when we did a 2 to the x, we noticed it was a little bit wider. When we did a 7 to the x, we noticed it came down here and came a little bit closer to the axis, that's all. But the characteristics are still the exact same, no matter what base you use. Your domain for your logs is still 0 to infinity. Your asymptote, x equals 0. Your range this time, all real numbers. And our x-intercept is still 1, 0. Okay, so it has the same attributes. And remember, we sketch. So I'm not going to stop and compare, are you closer to the axis? All you need to do is give me a sketch. Okay. And work your log transformations that way. Sometimes if you're too close to the axis, you're not going to see where your transformations are. And again, like your calculator doesn't do the greatest of jobs with the exponents. It kind of ends it off, except the color ones. And with the logs, the same thing. It looks like it kind of stops along your y-axis, but it doesn't stop. So really, that's all I was kind of getting with this one.
so how would you describe the transformation?
This one didn't have a transformation.
Oh.
This one is just using the change base formula. I didn't put a transformation on this. I just kind of wanted you to see, what does this base mean? And a base, where do you think a base 10 would go? Where would my base 10 go?
In comparison to the 7 and the 2,
Yes,
wouldn't it be sharper than the 7?
yes. It would come a little closer over here and turn and get a little sharper over here. Okay?
It's, yeah.
And base 10 all through the same point though. Base 10, you don't have to put a 10. You can choose to put a 10. If you're going to flip it to an exponential equation, put the 10. Same as the base ln e, put the e. So that's all that the base does. So I kind of wanted you to just make sure that you had a good understanding of that. The next one, I just put something weird out there. Let's
Uh-oh. Every time.
Okay, something weird out here. If you're going to use your calculator and your change of base log thing, that's absolutely fine. If you use your change of base, this is one fraction. So this is your top. This is your bottom, your denominator. Okay, that argument goes in the numerator. The old-fashioned way, we never had your change of base on your calculator up until maybe 3 or 4, well, it was around, but we were never allowed to use it. But since Algebra 2 came along, they let us use summations and they let us use change of base. So now we're able to do that. All right. Does yours say log base 5 or log base 3? 3, okay. All right, so I gave you some more transformations to do for homework. Describe all your transformations. Do your x-intercepts. Again, it's just kind of a repeat of what we did yesterday. I don't know that you guys were feeling as comfortable with this.
Being comfort.
So I just wanted you to try it and do some more and see where you are with that.